Welcome to DMOP Garage. We are back on the Okrasa build for the 57 oval, and in the last episode we were basically mocking up, which we're continuing to do right now, mocking up the engine. You can see here we have the barrels and pistons, got them all laid out, and we're going to do a mock-up because we have to put two-piece lifters, which I have the lifters in a bag here. These are the AA Performance lifters. We've got to work out our push rod length, so that's what we're going to do. This is one of the ones that we're going to use as a measuring device. So basically we're going to do a mock-up now. No pistons, obviously, just the barrels and heads, and torque it all up. We're going to put a little bit of bearing blue on the top here just to make sure our heads are sealing on the barrel top. Let's get going. Let's stick some barrels in. These have all been numbered. They've got some little stamps here, number 2, number 1, 3 and 4. And you'll see here, these are the special little pistons. And these have a little chamfer on the top of the piston. We're going to talk about that later. So let's get them installed. Righto guys, so we'll do some quick talking. This is just 7 foot-pounds just to get the initial head tightening. And then we've got okay guys, on to the next side. We've got the other head torqued up to spec. 23 foot-pounds, I think we've got it. Yeah, 23 foot-pounds for the head. 3 and 4 are on. We've also got our bearing blue just on that surface. And let's whack the head on and see how we go on this side. We've got the heads on. We had a little bit of issues just with this head going onto the barrel, and it was just the studs had a little bit of a kick in them. So anyway, it's all done. They're torqued up. We've got the rockers on, and we need to set length of the push rod. And
the offset of the rocker on the valve.
Right.
So just go through that too.
Yeah, well. So, and this is what we were just, we're looking at.
Okay, so the valve has to rotate when it's in closed position, so you need a slight offset. So the rocker tappet has to hit the valve to one side of the valve stem, only slightly. This one's too much, it's overhanging.
Yep.
This one is probably within tolerance, very close, and this one's on the opposite side.
Right.
So we're going to try and make them uniform by shimming the rocker in the position where we want it to strike the valve. The choice is yours. Minimal, doesn't matter.
Yeah.
But it's got to have some, especially with unleaded fuels.
And then the other little mod that we're going to do is get rid of the spring here and do a solid shaft in here, which I've just been reading on the forum. They say it's probably a better idea just because you're running more horsepower and you don't want things to move. So I suppose a piece of solid aluminium or thick-walled aluminium would probably work, wouldn't it? And
with a shim so it doesn't wear it against a rocker, you have to have something hard face there. And
we'll
also,
do that
we don't want these
on.
clips popping off.
Yep, so get rid of the clips and we'll bore a hole, and thread it.
A plate and shimming it out to the right space.
Yeah.
And that will hopefully help because we're talking a significant amount of lift and extra loading on these things from stock.
Yeah.
Right, they're a ratio rocker too, are they? 1 point compared to what they were?
1.15.
Rather than 1.1 or 1.0. Okay, cool. Right. So there's more lift, more loading. Valve springs are heavier than
They're
stock.
the Okrasa ones, yeah.
So they're heavier than stock too. So you're leveraging and loading more, so you want more capability of these things for not shifting sideways and stronger push rods.
Yeah. So
significant,
yeah. So that's what we've got to do now with the rods. So we have the two-piece lifter which is we talked about before. Yeah, that's the 2.2. You can see there it's got the little, I don't know what you call that, the little surface, I suppose, little cup that's going to go inside there. And then we need to work out our length.
And make sure that the radius of the cup is suitable for the receiver.
Yeah.
Because we want to make sure that it's in. And we need to know that the rocker angle is not going to impede on any parts of that with the extra lift. And we're looking for coil bind too when it's at full lift. Right. So the idea is we want to try and make the tappet so it strikes the valve. If that's the valve stem, the tappet part of your rocker is going to hit there. Sorry. And then when it's at full half tilt, this is a real mock-up, isn't it? Maybe it fall off the bench. That's it. So this is our little tappet. We want it to hit there, and then as it goes through its throw to there, we want the exact half point of the lifter to be perpendicular to the valve. So basically, when the rocker's in half lift, you want it to look like that.
Yep.
Square.
Right.
And then at full lift, we want to make sure it doesn't bind. When it comes back, it doesn't hit the rocker cover.
Right, gotcha.
Well. Okay, cool.
So we've got to do some cutting and some measuring, and we'll bring you guys back in once we've worked out our length.
And we're changing from the original diameter.
Yeah, which was 7 mil?
About 7 mil.
7 mil.
To a later model rod.
Yeah, 1600.
Yeah, and we're using a 2-piece lifter. So the overall lift...
Yeah, we've got to basically cut them down.
Chop that down. This is my dodgy adjustable rod from the 80s. That's probably the last time I used it was been the 90s. I don't know. It's been a long time. So we're going to adjust the push rod so we get that effect of the 90-degree push rod at half lift, which you've got to measure off. And this is slightly heavier in terms of weight, which is not great in terms of like inertia for all your lifters and rods, your valve geometry, which needs more spring pressure to bring it back under motion. But it gives a thicker wall to cope with the heavier spring pressures and higher lift on that. Because the more you lift the valve, the more you're pressing the spring down, which gives it more resistance to...
Right. Having issues,
Okay, cool.
All right. Righto, guys. So it's Fun Facts with Oven Boy again. And we're talking about all sorts of stuff, lifter, push rod, and, I don't know, bread maybe. I don't know.
Well, that's another 25 minutes out. But
okay, we're doing some drawings here.
Okay. Please don't be hypercritical on the drawing.
Oh, yeah, so you're getting out of 10. You're getting a score out of 10 on this one.
It has been a long time since engineering drawings, but anyway. That's a cam lobe, believe it or not.
Okay.
So, we're going to work out what we're doing. Okay, we're increasing the lift, we're increasing the RPM. So we have to accommodate that by increasing the strength of these components, because ultimately they're all ruled by a simple formula: force equals MA. A is determined by the RPM of the engine. Something like that. Mass is determined by each component: the lifter, the push rod, the rocker, the tappet, the valve, and the spring, retainer, and clips. All of them have a mass. They all have to move when it reciprocates up and down. The more it moves up and down, the more displacement, the more force is added too, because you're accelerating, you're pushing the spring further down. The force on a spring is the spring constant, which is, say, K, by the distance it moves downwards, which is governed by your lift. Okay, these are all basic engineering formulas, but they're the two that rule for your strength.
Yeah.
Okay, so if you're increasing your lift, that's your D, you'll increase your force. If you increase your RPM, you're increasing your force. If you increase your mass of any of those components, you're increasing the force. The force is taken up by friction on your cam. It's also taken up, it'll have an effect on your bending moment of the push rod. So if they've got a thing called a Euler's critical load, which doesn't matter what it is, but basically it is the principle of, if you've got a stick like that and you push hard enough, that stick will bend sideways. It'll try and crumble under the load. Once it goes sideways, it's all over.
Yep.
And that can be seen sometimes when you have a too high a lift or going too fast, and you'll see it's got scuff marks on the side of the push rod
when it's starting to distorting.
And it's hitting the tube.
Yeah.
Okay.
Yep.
We don't want anything like that to happen.
Yeah.
But if we make a heavier push rod or a stronger push rod, usually it comes with an increase in mass. and that's when you've got your chrome moly rods and all sorts of stuff. But they're also temperature dependent. So a chrome moly rod will expand at a different rate to an alloy rod. So there's got those little extra things as well. So without getting too critical, we need to minimize the mass of everything we can do to accommodate the loading that we're going to anticipate at the RPM that we want to run.
Right.
And everything weakens with heat.
Yeah,
so the hotter your motor runs, things soften.
So realistically, then the alloy push rod, because it can dispel the heat quicker, is probably better than the chromoly, but not as strong though.
I wouldn't go into that theory. It depends on the wall thickness of the alloy, but it's made to expand at a similar rate to the magnesium alloy case and the heads and all that sort of stuff. So it's similar. That's why you have your 6th hour clearance, 5th hour clearance racing, all that sort of stuff. Okay. So I'll just show him with Nico that we just weighed his lifter geometry mass.
So there's the stock 36 horsepower lifter.
Yeah, and we weighed that in at and the it's all working on the freezer at the moment, so this is just really rough. The motor's running in the freezer, so it might be upset, but it's not. Okay, so we're running 86 grams from his push rod assembly.
Right, that's the stock. That's the stock 36.
That's a stock 36er.
Yep.
We're using 2-piece this time, so we're going the one.
Yep.
Right.
AA Performance.
AA Performance. That's 95 grams on its own without the push rod. Now we're going to use the later model push rod, which is
1600.
1600, and shorten it probably about at least
30 mil.
Probably 30 mil.
Yeah.
20 to 30 mil. So all up, that weighs 133. Take away, what was the difference?
125. We said it was going to be close to.
About 125. Okay.
Yeah.
So we've gone from 86 grams
up to 125.
Yeah.
Roughly.
86 versus 125 grams. That's just in the push rod. I don't know what the spring pressures are on the Okrasa head, and I don't know what the rockers weigh, but its rotational mass is different.
Yep.
Okay, so it's not going to be an issue. So anyway, that's a consideration. So that's a significant mass on its own, just with a push rod.
Yep.
Okay. So Okrasa would have gone through the design of that to design it against a 36, I suppose. I don't know. Yeah, that's a start.
Yep.
Okay.
So we've got to start dissecting some rods, and we've got to get lengths first.
Yeah.
Yeah. So
that's why we're opting for the thicker rod.
Yeah. Okay.
And shorter it is, the less it's prone to bowing too.
Oh, of course.
Yeah.
Yes.
Yeah.
Which is probably Porsche technology 356, I'd imagine, wouldn't it?
Yeah.
That's probably where they've got their research.
That's a stock 1600 length, and that that's actually. Well, look, I'm opening just for you guys. Made in West Germany, original lifters, Volkswagen 1600. I don't even know if I can get these anymore anywhere.
Probably not.
German made, back from I've had these since 1980. I'll be using them in my motor for Millibug, so.
There you go. Excellent.
So there you go. Stock factory lifter.
Yeah.
Been sitting there for a while. Let's go and see what this would weigh. So stock factory lifter, 97 grams. Wow. That's more than I thought it would be. Versus an angle lifter, which I've got here, with plastic, 101 grams. So it's lighter than stock angle.
Yeah.
But the whole mass is 135, which is not far what you had before. Okay, cool. So that lifter mass is very similar to what you had here. 98 versus 95. 3 grams different. Just for interest's sake.
Cool. All right, we'll continue. Right, so one of the next things we're doing is working out our push rod length. Now, obviously, we have to cut these down, and because we're using the 2-piece lifter, which we talked about already. So we did have some problems getting these things, once we had cut them, getting the tip pressed back in. Because it's alloy, they were bending and giving us all sorts of issues. So we've come up with a way of doing it, which I think will benefit other people. When you buy these push rods, they are normally machined on the inside about 1 mil down or 1 mil thinner in the wall, so that you can press the tips on. So of course we didn't know that at first, and we bent a couple and it didn't work. So I will show you what Oven Boy's doing right now. Small amount, you can see in there, we're just taking that little section inside out, and then over here on the table we have our little jig that we've made, which is just a bit of pipe, and what happens is you run the rod inside it, which is stopping it from bending if you whack it too hard. We've got an old hydraulic lifter, which we've just ground off the top of it, and that's going to sit on like that. And then you go tappy, tappy, tappy with a hammer.
Solid lifter. That was a hydraulic one.
Oh, was it? Okay. Yeah. Solid lifter, yes. Oh, it's 1600, isn't it? Anyway, that's going to go on like that, and then you can tap your tip on and everything is good. So what we've done on the other side of the pipe here is we've also got another lifter, so that this is actually living inside on another mushroom like that, if that makes sense. So that's how we're doing them. We've got all these to cut out. We've actually measured our geometry on our rockers using our adjustable one, and now it's a matter of assembling them together. Here we go, fellas. So we've got, this is what we do.
I wish I had a 600
Rod, put it inside the hole, and then the little tippy tip just hops in like that, and then we use that on top and then tap it home. Let's do it. So this is just for us, our prosperity, and our measurements.
Not the setting so much, just the way to set the tool up, because that'll vary every
Well, this
time.
is what we did with the tool. So we've just got a couple of packers. We've got 1, 2, 3 packers, and then the tool
on its side.
on its side. Pretty ghetto, but it worked. It worked really well.
Very ghetto.
And that was our tip that we used to machine them. Now they're all done, and that was a really easy way. We're going to just spin it. Are we going to spin them up?
Yeah, I'm going to spin them.
Spin them up just to make sure they're not bent or anything, but this worked really well. That was a great tool to make, and that's the way to go. All right, so we are back at the DMOP headquarters, and we are on to porting and polishing the heads. Now, you can see the difference between, well, I've started on this one already, but this is stock, and what we're trying to do is get rid of all these hard edges. So if you have a look here, you have a very hard edge on here, which we want to take off. And also around the valve seat, just that hard edge along here and there. We want to take that off too. And then obviously we'll start going inside the ports as well and cleaning them up. Now you can see on this one, I have rounded this edge a lot and got rid of that step. Now obviously you don't want to touch the valve seat at all, so you've got to be very careful. Now I'm using a Dremel. You can use a die grinder, but I think for this we're not really taking a lot of material out of the chamber, so this is pretty much the little tip I've been using, and these little tips here, so pretty fine stuff. And believe it or not, the one that I'm using more than anything is this absolutely tiny weeny one here, and you can see that works really well for getting that little tiny edge off there. Yeah, so anyway, these are the ones I'm using, and a little bit of these sanding discs as well, that style. And just on the Dremel, but you know, I have done one head already, which I can show you. So this head here is finished, and you can see I've polished it up as well, got rid of all those hard edges. I've also gone inside here and opened up the insides a bit more, and also in there in the ports here. So we have to do a little bit more matching to the manifold, which I will do that after we get both the heads done. But anyway, that one's pretty much done. So let's keep grinding away over here and get these things polished up. So we are complete with the porting and polishing. So one thing I'm gonna have to do, I did match these ones to the carburetor gasket and also to the head up on here, as you can see. So that all works. What I'm having trouble with is I found some stock J pipes, but the orifice in the middle is actually not right. So this is only 27, the inside diameter, and I think this is closer to 32, so I'm going to probably have to get, let's check this again, yeah, 32. So that's not going to cut it, that's too restrictive, and we don't want to be sapping horsepower out of this sucker. So I might actually make my own set. I'll go and get some stainless steel maybe and some bends and see if I can weld up some J-pipe. Getting 32 internal diameter might be difficult. I'll have to look into that, but anyway, these are done. Let's head back to Oven Boy's place and we'll keep going with the assembly. Okay guys, so we got our gears sorted out. We actually swapped them over from the other crank, which was the original crank, and put the cam in, tested it, no binding, so we're all good. And now we can continue with the build. We are ready to put halves together, guys. We've gone and put our Loctite 518. We're using that as our case half sealer. And also a little bit of Permatex. This one's just for our sand seal, just around the rim of the sand seal, just in case. It's like Hylamar, same stuff. Okay, so I think we're good to go. I've got no other double check everything. Okay, slinger.
Goodbye. Did you put oil on the gears and the cam?
Yeah, I did oils on those and rotated it and re-oiled. So the only thing to just check is that sand seal. Once I slide this on, just make sure that goes.
I'll hold it in place for you. That's what that blue stuff actually goops up quite nicely into place. You're well off the mark.
I don't know what I'm doing here.
You're on, but yeah, the wrong kind, obviously.
Hang on, let me get.
Do you want me to guide in for you, Nick?
I'm looking at the wrong...
I can see it's been a while.
I'm looking at the wrong hole. Sadly.
It's been a while since you put an engine case together.
Yeah, what's that?
What's stopping you?
I don't know, something is...
Binding on the studs. So that's it, rock it down gently. That's it, good. Okay,
that seal went down.
Yes, seal's good.
Okay. So
just make sure it's square as I'll push it in as you tighten it up.
Now, we want to put goop behind...
Nuts, yeah. Hylamar's good for that too. Or the red, I don't know about the red stuff. You use the red stuff.
Yeah.
Okay, so it felt like I'm missing. Yeah, there you go.
Was here, wasn't it?
Doesn't matter, you're on it now. I would have gone to the back one, but that's alright.
As long, like you said, as long as you cross. Okay, guys, so we've got our bolts torqued up in the middle, and we're just making sure our sand seal is where it needs to be, which it's gone in nice. And we've got our gasket on for our oil pump, so we'll go and put that on. Okay, then we can put our cover on. You can see in the background here we have Scooby, the quality control expert, not doing too much but sleeping. She's doing a good job. Every now and again she'll check up on our work. Righto guys, so we have put a few more items on. We've got the Berg full flow oil pump cover on. I've also put the relief valve in, and yeah, everything else is looking good here. We do have to play around with just porting these a little bit more for the exhaust. It does fit. We just have to do a little bit of fandangling. I'll show the exhaust actually, because it's over here. One of the Abarth stainless steel German ones, which is pretty cool. Period correct, of course. And we just had to do a little bit of finagling with these pipes here, because they weren't quite, they're about 2 mil out on the hole, so just a rubber mallet and a bit of tappy and we're all good. So I've got to do a little bit of homework at home with some componentry. I've just got to clean up the fuel pump. That thing's just gross. So clean all that up and bring 356 Porsche fuel pump distributor, and the push rod tubes are very tight, so I don't know if I need to buy shortened versions. But we did put one on and it was completely bound right up. I can show you it here. This one here we put in, and you know, there's no room for it to actually coil back out. Like, they're completely compressed. So I don't know if that's an issue or not. I need to do a bit of research on that one. Yeah, so coming together. At least it's all gooped up, and yeah, we will continue soon. Okay guys, well that's what we're going to do it for this episode. We will continue on the Okrasa motor We've got some carbies and other bits and pieces to bring up, and we can start mocking up the tinware as well. So catch you in the next episode, and thanks again for the new subscribers.